In this video, we're going to talk about implicit differentiation. And I want you to understand that the word implicit is actually, in my mind, related to the word imply, like the way we use it in English. So let's talk about explicit versus implicit. Now, if you talk about somebody is explicit when they explain something to you, they're sometimes got way too much detail for what you want. They tell you every single detail spelled out, no doubts, everything's clear as a bell. Sometimes too explicit. Okay, but it's most definitely said, this is exactly what you're going to do. This is exactly what I want it to look like. This is exact. If someone implies something to you, it's a little bit more vague. You sort of have to put two and two together and come up with four. They may kind of talk around the topic and you have to sit there and think about it a little bit and go, well, maybe, okay, yeah, I think I've got the idea of what's going on. Okay, so somebody that's going to imply something is not spelling it out in explicit terms, right? They're just sort of talking around it, referring to it obliquely. Okay, so let's talk about explicit functions versus implicit functions. So an explicit function is something that spells out exactly what y is compared to x. Okay, so it might be something like y is 2x squared plus 3x minus 5. That says exactly how you get y from x. It could be y is the square root of x plus 1 over x minus 2. Okay, that's explicitly stated. That says if you can have an x and substitute it in here, then I can give you exactly what y is. All right. It's also the way your calculator, if if you're using like a TI, your calculator wants you to put things in y equals. And so it wants a function, it's what it wants. If you have something like x squared plus y squared equals, let's say 25, that's a circle. You could sketch it for me, most likely, all right? But you can't put it straight into your calculator because it's not set up as a function. You'd have to do a little bit of work for that, right? Move the x squared over, square root both sides, plus or minus, and you could get the top half of the circle and the bottom half of the circle. And it's implied how you get y from x. So you have to pick an x, you put it in, but instead of just adding or subtracting or doing whatever and out pops y, you have to do a little bit of work, moving things around and then square rooting to get to y. So it's an implied relationship. It might be something a little bit more complicated, like x squared y squared plus 3xy minus 4y equals 5x. Something like that, where the x's and the y's are all mixed up together. So it's not clear cut how you get from y to x or from x to y. It could be something, it could even be a trig function. But if you've got x's and y's tangled up, woven together inside of the function where it's not clearly y is equal to all this stuff in terms of x, right? Then it is implicit. The relationship between the two is implicit, all right? So let's try one. So what if we have x squared plus xy minus y squared is equal to 8? All right, now this, you can tell it's implicit. Sometimes your teachers will tell you to use implicit, but you should kind of be able to tell by looking, because it's not y equals and all your x's are over here. Now, the way I sort of look at it is this. So these y's that are hidden in these functions, they represent some relationship, some function that is not clear cut. Okay, so each y has buried in it some relationship, okay, that is itself differentiable. I just don't know what it is because it's all in here. So what you do is you take the derivative just like you normally do, product rule, quotient rule, power rule, whatever's going on, but you're taking the derivative with respect to x, all right? So if you take the derivative with respect to x of each side, everything that is an x, when you take the derivative of it with respect to itself to x, it acts like it always has. But when you take the derivative of y with respect to x, because they don't match, right? You have the derivative of y with respect to x. You don't have, to be honest, dx over dx, right? The derivative of x with respect to x is just 1, right? So here we go. Every time we get a y, we're going to use the power rule, the product rule, whatever rule we're going to do. And then you have to remember to loop back in and take the derivative of y with respect to x. So it ends up with an extra dy dx. So let's start and get busy. So x squared is just an x. So taking the derivative with respect to x, I'm good. It's a power. I bring down the power, leave the x alone, take 1 off the power. If you're now stuck in the chain rule and you think I should loop back in and take the derivative of the inside, well, the derivative of x is 1. So you would just end up with a 1 out here. All right. Now, plus. Now, this part right here is a product. And sometimes this can sneak by if you're not kind of slowing down. So slow down and think about it. So it's a product. So you do not just take the derivative of each piece. It is the first times the derivative of the second. And the derivative of y with respect to x is dy dx plus the second times the derivative of the first, and the derivative of x with respect to x is 1 minus y squared. And we're taking the derivative with respect to x of a y. So it's like the chain rule. So you bring the power down, leave the inside alone, take 1 off the power, loop back in, and take the derivative of the inside. And the derivative of 8 or any constant is 0. You okay? Now, some people, and I don't have any problem with it, but I want to show you something. Some people want to use y prime instead of dy dx, which is just fine. And if you did, you'd have 2x plus x y prime plus y minus 2y y prime is equal to 0. Whoops. I said it, didn't write it. Minus 2y y prime equals 0. Now, as you can tell, if you get buried into some of these problems and they get really deep and intricate, this y prime or this y prime, sometimes you miss the prime, the little hash mark, and all of a sudden it turns into like xy, or maybe this becomes y squared. So I tend to ask my students to not use y prime just for their own good. If you like y prime and you can keep up with all the primes, or your teacher likes y prime, there is nothing wrong with that. Just be sure that you don't lose those primes, those little hash marks on the way. All right. Now, so I'm going to use dy dx. And so what I'm trying to get, remember when we want the derivative, is we've always said y prime equals, or we've said f of x prime equals, but that's also another way to say dy dx equals, right? So what I'm going to try to do is to group my like terms. I'm going to get my dy dx terms together, move everything else to the other side, and then I'm going to factor out the dy dx and solve, sort of like factoring, okay, the way you used to factor. So I have an x dy dx term, and I have a minus 2y dy dx term. And I'm going to move everybody that's not a dy dx over to the other side. So I would have a minus 2x and a minus y. Then I'm going to factor out the dy dx. And that would leave me x minus 2y. equals minus 2x minus y. And I divide both sides by x minus 2y. So dy dx equals minus 2x minus y over x minus 2y. And you could factor out that negative in the top if you want to, but you don't have to. Well, not in my world. Your teacher may want that, but in my world it's fine. Okay? Now, please note that nothing in here cancels, okay? You can't cancel this x into anything on top because they both don't have an x. You can't cancel the 2 because they both don't have a 2. You can't cancel a y because both terms on top don't have a y. So this is as much as it's going to get. All right. I have a really difficult, it kind of grew on me, difficult one for plan for next, but I'm going to save it to the end. All right. So let's try x squared plus y, the whole quantity cubed is equal to y. All right. So let's talk outside and inside. So the outside is a power rule. It's got the chain rule. It's implicit. So we're going to do everything we normally do with x's. But every time we do the derivative of a y, we have to loop back in. All right. And remember the dy dx's. All right. So to do the power rule, you bring the power down, leave the inside alone, take 1 off the power. Okay, loop back in, and we're going to take the derivative of x squared plus y. So the derivative of x squared is bring the power down, leave the x alone, take 1 off the power, plus. And the derivative of y is not 1. Okay, the derivative of y is dy dx because we're taking the derivative of y with respect to x. And there's not a match, okay? Equals, and the derivative of y on the other side with respect to x is dy dx. All right. So let's see. This is the distributive property on the left. So we would have 6x x squared plus y squared plus 3x squared plus y squared dy dx equals dy dx. And I'm just going to put, I'm just arbitrarily choosing to put them on the left because you don't always have to, put the dy's on the right. You don't always have to put them on the left. So I'm going to leave these alone. And I'll have dy dx minus 3x squared plus y, quantity squared, dy dx. Factor out the dy dx. And you have 1 minus 3x squared plus y squared. So dy dx is 6x x squared plus y squared all over 1 minus 3x squared plus y squared. Okay, after you divide both sides by this. So you can get dy dx by itself. Doing okay? Okay. It's not as bad as you thought, right? It's a little weird, but it's not as bad as you thought it was going to be. Implicit differentiation sounds like, oh my gosh, I'm going to die. Right? It's not that bad, right? Really. Some of the stuff that you did in the chain rule, it's pretty bad. This is you've seen worse. We haven't done any story problems in this video series yet. I'm going to lump them all into 1 or 2 videos at the end. You know, you always sort of have to compare and go with, well, it's not as bad as. All right, let's do 2 sine x cosine y. You knew we had to get some trig in here somehow, right? All right, so we have the 2, and then we have the product rule. So we have 2, and I'm going to pull that out. and do the product rule. So it's the first times the derivative of the second. Now cosine is the outside, y is the inside. So the derivative of the outside is negative sine. Leave the inside alone, right? That's the inside is y. Loop back in and take the derivative of the inside. See how this can kind of, you have to keep your mind on this implicit. It's not horribly difficult, but if your mind wanders, that dy dx just falls away at the wrong time. Okay, that's the first times the derivative of the second plus the second times the derivative of the first. And the derivative of sine x with respect to x is going to be cosine x. You okay? All of this times 2, and the derivative of 1 is 0. All right? Okay, so then we have minus 2 sine x sine y dy dx plus 2 cosine x cosine y. I just put them in alphabetical order. Okay, equals 0. So I can move the 2 cosine x cosine y, since they don't have any dy dx with them, to the other side. And I have minus 2 sine x sine y dy dx. Divide both sides. So you have dy dx equals, and the 2's cancel, right? And you've got cosine x cosine y over sine x sine y. Now, you can't do anything with cosine x times cosine y. It's not like it's cosine squared xy. Your trig teacher would just be like, no, no. Okay, so cosine x times cosine y is, you can't do anything with that. However, cosine x over sine x is cotangent x, and cosine y over sine y is cotangent y. Okay, so we have cotangent x times cotangent y. And sometimes it just feels better to put parentheses around the x and the y, and sometimes it doesn't. You follow whatever your teacher wants you to do. And this is your answer. All right, so then let's try another one. So how about e to the xy plus x squared minus y squared equals 36. So this e to the xy is like e to the u. And remember, the derivative of e to the u is itself again. And then you loop back in and take the derivative of whatever's going on up here in the u and the power. Okay? So u in this case is xy. All right? It's x times y, which is a product. Okay. So what's the derivative of e to the xy? Itself again. Then you're going to loop back in and take the derivative of whatever's up here with the power, and that's a product. So it's the first times the derivative of the second, dy dx, plus the second times the derivative of the first, which is 1, right? Plus the derivative of x squared with respect to x is 2x. The derivative of y squared with respect to x is 2y. Leave the inside alone, take 1 off the power, loop back in, and take the derivative of the inside. And the derivative of 36 is 0. Okay? So when let's see if we can maybe save a step. So if you look for the dy dx terms, you have x e to the xy from here, and you have minus 2y from here, okay? Equals. Then you bring the minus 2x over here, and this e to the xy times y is going to go over there. So you have minus y e to the xy. If that just, I just skipped like 2 steps. So if you're stuck right in here, stop the video, put the extra steps in where you're going to actually subtract, distribute out that e to the xy and then move things over and see if it makes more sense to you. And so you have dy dx. This is what's nice about a video is you can stop me anytime you want to. Can't really do that with your teacher when it's live. All right, so you'd have minus 2x minus y e to the xy all over x e to the xy minus 2y. And I know it's really, 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 really tempting to try to cancel something out of here, but there's nothing in common to factor out. So there's nothing in common that you can cancel because you have to have factors to cancel. Every time I say the word cancel, I think back to that teacher that I had that would just about die every time you use the word cancel. And she gets so aggravated with me. So when I subbed for her class, if she was gone, I made sure not to use the word cancel. You should say reduce. All right. Now, I kind of told that little story just so you can have a breather or be annoyed, whichever. All right, but kind of step back away from implicit because we're going to do implicit again. But what we're going to do is we're going to do the second derivative. We're going to go through the first derivative and then do the second derivative. And I want you to watch what happens. And there's some little kind of cutesy things. So I want you to kind of step back, let your brain relax for a second, and then get back in. All right, so here we go. X squared plus y squared equals 25. That lovely little circle thing that I told you about at the beginning. All right. Now, so we're going to take the first derivative, dy dx, right? We're going to take the derivative with respect to x. So the derivative of x squared with respect to x is 2x. The derivative of y squared with respect to x is 2y. Leave the inside alone. Take 1 off the power. Loop back in. And take the derivative of the inside. And the derivative of 25 is 0. All right. So I can move, since this has some little cute, what I think are kind of cute things. Actually, I think this is cute. I'm going to slow down and take this a little slow because when I do this type of thing in class, the students, when they get to the end, they go, wait, wait a minute, back that up. And I don't want y'all to be too put out by doing too many steps at one time. So I'd have minus 2x over 2y. As you can tell, when I teach class, the students, out of self-defense, they, I don't know, we tease each other a lot. All right, here we go. So the 2's cancel. So the dy dx is equal to negative x over y. They work really hard. All right, now that's the first derivative. Now the second derivative, we've done things like y prime is the first derivative, y double prime is the second derivative. If you did the third derivative, you'd have y triple prime and so forth. And we'll talk about that when we get to applications, otherwise known as story problems. You can do dy dx is the first derivative. Okay, d squared y dx squared is the second derivative. And I think that the way they got this is if you have dy dx and you're going to take the derivative of it again with respect to x. Do you see how these two parts right here make this d squared y? Because there's two d's. And this part here, there's dx times dx, and that's that dx squared. Okay. All right. So here we go. We're going to take the derivative again with respect to x. So what we have is we take the derivative with respect to x of both sides. I was going to change that to a different color, but I'm going to leave it like that. All right. So that's what we're going to do. Now I'm going to erase it so you can have seen it. And here we go. So the second derivative is, I know I have bad handwriting, but, and it's worse on this surface as opposed to on the wall on a whiteboard, but sometimes even I think it's pretty bad. All right, so I'm going to pull the negative out, and I'm going to do the quotient rule. All right, so the quotient rule is the bottom times the derivative of the top. Okay, so the derivative of x with respect to x is 1, minus the top times the derivative of the bottom, and the derivative of y with respect to x is dy dx over the bottom squared. All right? Now, not too bad. Now, they don't like the second derivative in terms of the first derivative because that's what you've got. So we're going to sub in, and we know what the first derivative is, that dy dx is actually minus x over y, right? Because we just found it up here. So we can substitute that in. All right, so we have minus, this is y, minus x, and that dy dx is actually minus x over y from before over y squared. Okay, doing all right? I know I've been asking you that a lot in this video, but even though I think you're going to get the hang of this pretty quickly, you just sort of need a breather every once in a while. All right, now this is a complex fraction, so we are going to multiply the top and bottom by the least common denominator, which is this y right here. So we're going to multiply top and bottom by y. So you have minus y times y is y squared minus this y times this x over y is canceled. That's going to cancel out this one. And we have this negative times this negative, right? So instead of a minus, I'm going to have a plus. This is x times x is x squared. Okay, so do you see where all that came from? This y is going to cancel out this y. This x times this x is x squared, and the two negatives make a positive over y cubed. Okay? All right. So the first kind of cutesy thing, if you want to call it that, or the first part of the technique I think it's actually is cute. I do think it's cute. Okay? In the fact that it makes me smile. All right? So when I see this part, I don't know why it makes me smile. It just does. All right. So the first thing you have to pay attention to is you're going to have an embedded first derivative. So you have to go back and pick up the first derivative that you just found and insert it in there and then clean it up again. Okay? So we've cleaned it up again, and this is the second derivative. And sometimes, not always, okay, but sometimes look over what your answer is, kind of look at where we started. Okay, so this is where we started, and this is where we ended up. Now, do you see anything in common between where we started and where we ended up that looks kind of like, oh man, we're kind of back where we started? All right, do you see anything? Okay, do you see this part right here? This is x squared plus y squared. And even though this is backwards, so this is x squared plus y squared, right? And the initial problem statement said x squared plus y squared is really equal to 25, right? that's what it's worth. So what we're going to do is to change this to minus, and x squared plus y squared is actually 25 over y cubed. And I really do like that. Okay? All right. Now, it doesn't always do that. It sort of depends on the problem your teacher picks or makes up. Sometimes they like to see that too. Sometimes it doesn't clean up that way. So don't expect that it always happens where something that you had here turns out to be up there, but it happens enough to where you should check it out. Now, the last one I want to do is to find a tangent, and it's a little bit more complicated. So I'm going to scroll all the way back up here. We're going to get to those graphs in just a minute. All right. And we are going to talk about this function, 3x squared minus 4y squared is equal to 2x. Okay? And eventually I'm going to get to where I want to find the tangent to this curve at x is equal to 4. Okay? That's my end goal. But for right now, in order to find a tangent, don't you have to take the derivative? Because remember, to find any equation of a line, you need a point and you need a slope. And the slope comes from the derivative, right? Because the derivative is the instantaneous slope of this curve anywhere along its length. So let's take the derivative. So the derivative of 3x squared with respect to x is 6x. The derivative of minus 4y squared with respect to x is minus 8y dy dx. And the derivative of 2x with respect to x is 2. Okay, so dy dx, we move the 6x over, so you have 2 minus 6x, okay? And you're going to divide by a negative 8y. All right, so dy dx is, and I'm going to factor a 2 out of all of those 3 terms out of the top and the bottom, and I'm going to divide through by the negative, so I'd have negative 1 plus 3x over 4y. All right, now to find the tangent line, I need a slope and I need a point. Okay, so for the point, I want to use that original function, 3x squared minus 4y squared equals 2x. Okay, and I want to use x is equal to 4. So I'd have 3 times 4 squared minus 4 times, we don't know yet. It's hard to break a habit of putting that in everywhere there's a variable, because that's the problem with implicit, equals 2 times 4. Okay? So you'd have negative 4y squared is equal to negative 10 after you do the math. So y squared, is equal to negative 40. I actually write all these things out, and sometimes I get distracted myself. Okay, y squared is equal to 10. So y is equal to plus or minus the square root of 10. So you have 2 points. You have 4 square root of 10 and 4 negative square root of 10. Okay? All right. Did you recognize that this isn't hyperbola, right? Because they're both squared, so it's in the kind of the circle family, all right? And the negative sign says they point in opposite directions, so it's a hyperbola. Now let's do the slope. Dy dx is minus 1 plus 3x over 4y, right? So okay, so I need to know what x is and I need to know what y is. And so I've got 2 y's, right? Plus square root of 10 and minus square root of 10. So if I use the 4 and the square root of 10, Okay, so I have to use both, right? It's not just an x thing. So when I do that, I would have dy dx equals minus 1 plus 3 times 4 over 4 times the square root of 10. So this turns out to be 11 over 4 square root of 10. That's the slope. Okay? Then using 4 negative square root of 10 dy dx equals, all right, so you would have, let me scroll this down, negative 1 plus 3 times 4 like before over 4 times a negative square root of 10. Okay, so negative 1 plus 12 is 11 over negative 4 square root of 10. So you have negative 11 over 4 square root of 10. That's that one's slope. So I'm going to have two tangents. Okay, so here we go. So using 4 square root of 10, and the slope is 11 over 4 square root of 10. And then using 4 negative square root of 10, and the slope is the negative 11 over 4 square root of 10, right? So these are going to be my two tangents, right? Then I would have y minus y1 is equal to the slope times x minus x1. So you'd have y is equal to 11 over 4 square root of 10 x minus 44 over 4 square root of 10, because I'm just doing the distributive property, and then I move the square root of 10 over. And that's not a very pretty equation of a line, but if they want an exact, this is it. If you start running this on your calculator and doing what's the square root of 10 and what's minus 44 over the 4 square root of 10, then you're going to get an approximation. So if your teacher tells you to approximate the answer to the nearest tenth or something, then do that. If they don't tell you to round, you're not supposed to round. I don't know when they're supposed to tell you that, but somewhere in your past, they're supposed to have explained to you that if the teacher doesn't ask you to round it off, you're supposed to leave it with all these radicals and whatevers, because that's exact. Okay? So then over here, you would go y minus a minus square root of 10 equals a negative 11 over 4 square root of 10 times x minus 4. So y equals negative 11 over 4 square root of 10 x plus 44 over 4 square root of 10. And we had a plus square root of 10 on the left, so when you subtract it, it's like this. Now, sure enough, I should have gone, just looking at it, I should have gone maybe right in here and said that reduces to 11 over the square root of 10. I wouldn't have hurted you to do that. And this would be 11 over the square root of 10. Okay? But I have to admit, if I had asked you to do this problem and that was the last thing you didn't do, I would have just said, okay, that's just fine, because, I'm just proud that you got down to that part. All right, now, I was like, I did this one, I made this problem up, and I did this one, and I thought, I'm just not sure. Before I put this on a video, I am just not sure. So I graphed it, and this is using that Desmos calculator that they were so nice to let me use. So here is the hyperbola is sitting right in here. That's a hyperbola. And then the tangent to it over here at x is equal to 4 is right there, and it's so close, so there you can see it superimposed. And then here's the other one at 4 down here. So we had one tangent up here, one tangent down here, because we had 4 plus, 4 square root of 10, 4 negative square root of 10, right? These 2 points. Okay, so I hope that helps. Implicit just means that the original function is intertwined, where the x's and y's are not separated out, and you don't have y equals, right? So, and that just means you're going to use the chain rule on anything that's a y and loop back in and come up with a dy dx. So I hope that helped. Hope that clarified things. There's links at the bottom. Please don't forget those to take you to the next video and the previous video and to practice problems. Please remember to like the video or to subscribe to it, because the more times you do that to these videos, then the more likely that other people can see them and get some help. Hopefully it's helped you. So please don't forget to do that. See you later.